Hey guys, very good evening everyone and welcome to another session of Domain Analytics by 360 DigiTMG. Am I audible guys? Quick confirmation in the chat window. Everyone, am I audible? Quick confirmation guys. Perfect. So guys, since past few days or since last week, we have been doing the discussion about domain analytics, and in this we were specifically seeing about cyber security analytics. We have discussed about what is cyber security, what are the threats, various threats that we have observed, in the cyber security field. Besides this, we also talked about applications of cyber security. We talked about, project management methodology, which is called as the CRISP MLQ, cross-industry standard process of machine learning with quality assurance. Then we discussed about EDA, that is the pre-processing stage. We all discussed various type of things over it. We also discussed about unsupervised learning, that is the k-means clustering. On Friday, we discussed about k nearest neighbor. And today we are going to discuss about decision tree. We will take an overview of what is decision tree, how the things work, and then we are going to see the practical of a use case where I have used decision tree. I have actually implemented a lot of models, and decision tree is also the one model which I have implemented for network intrusion detection. So decision tree was also one of the models which I have used over there. I'll be showing that also in the end. Okay, moving ahead, when we talk about decision tree. When we talk about decision tree, so a decision tree is a flowchart like a structure in which each internal node represents a test on on an attribute, whether a coin flip comes to heads or it is coming to the tail. Each branch represents the outcome of the test. Each leaf node represents a class label, right? Class label. That is decision taken after you're computing all the attributes. It is also said that the decision is the most powerful and the popular tool for classification and prediction. This is one of the most powerful tools you can say we have in the database. Now, when we talk about classification guys is a two-step process. First step is a learning step. And the second one is a prediction step. In the learning step, what happens is the model is developed based on the given training data. We have seen that in the previous sessions before. What happens is in the prediction stage, the model is used to predict the response of the given data. Decision tree guys is one of the easiest and the most popular way. Besides being the powerful and the popular tool, it is also one of the easiest way of classification algorithms to understand and interpret. When we talk about decision tree algorithm, this belongs to a class of supervised learning, where the model is the training data is given to a machine learning and it gets trained. Unlike other supervised learning, the decision tree algorithm can be used for solving your regression and classification problems. What is the goal of the decision tree? The goal of the decision tree is to create a training model that can use to predict the class or a value of a target variable. How? By learning simple decision tool. This is how it is achieving the goal. Now, this simple decision tool, rather I would say simple decision rule, not the tool. My bad. Pardon me for that. Now, these simple decision rules, they are inferred from where? They are inferred from the training data, your prior data, training data. Simple decision rules are, taken from there. Now, in the decision tree, your, for predicting, when we talk about prediction, so in decision tree for predicting a class level for a record, say we have a record over here. Now, for predicting the class level of that record, we start from the root of the tree. We compare the value of the root attribute with the root's record. On the basis of the comparison, what will happen? We follow the branch corresponding to that value, and then we will jump to the next node. Just imagine like a tree. This is a tree. Imagine it in the form of a tree. Talking about the types, there are, you can say one is categorical variable decision tree. Another one is a continuous variable detection tree. What happens over here is decision tree which has the categorical target variable. If it is having categorical target variable, it will be called as categorical variable decision. And when you are having continuous target variable, then it will be called continuous variable decision. Now, let's say we have a problem to predict. There's a problem that we are having, that we want to predict whether a customer is going to pay his renewal premium with an insurance company or not. So output is going to be yes or no. Here we know the income of a customer is a significant variable. Income will be a significant variable. But your insurance company, it is not having the details. What details? Income details for all of the customers. They don't have that. Now, as we know that this is an important variable, then we can build a decision tree to predict customer income based on occupation, product, and various other variables. Pertaining to all those variables, we can make a decision tree which is going to predict our income. Now, what happens over here in this case, we are trying to predict value for a continuous variable, right? So this is how the things work in the decision tree. Now, when we talk about various sorts of say terminologies which is being used in the decision tree. First terminology which you will be coming across is your root node. Root node, guys, it represents the entire population. Entire population or sample. And this further gets divided into two or more homogeneous sets. We have seen what is homogeneous set and what is heterogeneous set. Another term which you will come across is splitting. When we talk about splitting, this is the process of dividing a node into two or more subnodes, as the name says, splitting. Decision node. Decision node, when let me put it this way. Okay, when a subnode splits into further subnodes, then it is called as your decision node. Then we have something called as your leaf node. What is this? Leaf nodes are those nodes that does not split. Nodes that do not split, that is called as a leaf or terminal node. We have something called as pruning. Pruning also happens, right? What happens when you have a tree at your place or a plant at your place? You will see that your gardener, he does the pruning of that tree, of that plant. In the same way, pruning and decision tree, it means when we remove a subnode of a decision, this process is called as a pruning. You can also say that this is just the opposite of your splitting. Pruning is your opposite of splitting. We have something called as your branch also. The subsection of the entire tree is called as your branch or your subtree. This is also called as your subtree. And then we have parent, child. All these are terminologies guys, which will be coming across, while working on their decision tree. What is this? A node which is divided into subnodes is called as a parent of a subnode, whereas the subnodes are called as your child of the parent node. Okay. Now, decision trees classify the examples by sorting them, down the tree, downward from the root to the same leaf or terminal, with the leaf or terminal providing the classification of your example. Each node in the tree acts as a test case. Each node is acting as what? Test case. For what? For some attribute. Okay. And each edge descending from the node corresponds to the possible answers. Possible answers to what? To your test cases. This process is recursive in nature and is repeated again and again for every subtree that is rooted at a new node. This is how the things work in your decision tree. These are the terms that you should be aware of. Construction of a decision tree. Again, a tree can be learned by splitting the source set into subsets. We discussed that previously. Based on an attribute value set. See, this is what I was telling you. This process is repeated, recursive in nature. What I told you 2 seconds back. The process is recursive in nature. It is repeated on each derived subset in a recursive manner, called as a recursive partitioning. Okay. Moving ahead. Yeah. And here we have this example of, decision tree for plate tennis, and all these things are happening over here. This is again related to your concept of Abhilash. Would you stop scribbling? Please delete Abhilash. I would appreciate. Abhilash. Yeah, Abhilash, please delete what you have scribbled on the screen, Abhilash. Otherwise, I have to remove you. Yeah.
Yes. It's been done. It's been done.
Yeah, please delete it, Abhilash.
Okay.
you will be getting an erase button or a bin button. You can click on that, click on the bin button. Yeah, thank you. Kindly
Okay.
refrain from all these activities, Abhilash.
Sure.
Yeah, we are all here for learning something, right? And we are having a very less time, so we should try to utilize it. Okay. Here we are having an outlook of you know, what is going to be, whether it is going to be a sunny weather, whether it is going to be an overcast, whether it is going to be a rain, and you know, suppose it is overcast, yes, humidity, wind, if humidity, whether it is going to be high or low. Well, all these kinds of things is what you can do using a decision. Now, talking about the strength of the decision tree method. So what are the strengths where we can capitalize our decision? First, decision trees are able to generate understandable rules. Second, decision tree guides perform classification without requiring much computation. You don't need, you know, to put much computational burden to perform your decision to classification. Decision tree are able to handle both continuous and categorical variables. I showed you on the first slide, I showed you this. And decision tree provides a clear indication of which fields are most important for prediction or your classification. These are the strengths of your decision tree method. Now, if it is having, you know, strength, then it is quite obvious that it will be having some weakness also, and we should be aware of it, right? As a data scientist, we should be aware of all these things. Okay. Now, decision tree guides are less appropriate for estimation tasks, where the goal is to predict the value of continuous attributes. Whenever we have this challenge of, you know, predicting the value of continuous attributes, this is where our decision tree becomes less appropriate. For what? For your estimation goal, estimation task. Decision tree algorithm is also prone to errors in classification problems, with many class and relatively small number of training examples. When decision tree, we talk about decision tree, it can be computationally expensive to train. Costing is very important for us as a data scientist. So decision tree can be computationally expensive to train. The process of growing a decision tree is computationally expensive. At each node, each candidate splitting field must be sorted before its best split could be found. Now, what happens in some algorithms? The combination of these fields are used and a search is made for optimal combining weight. Pruning algorithms, I discussed you about the term called as pruning. See, pruning algorithm is also, you know, expensive, since many candidate subtrees must be formed and compared. All these things are your, you know, various weaknesses when we talk about decision tree method. Okay, moving ahead. Even before we come to this point, let me quickly tell you. When we talk about, you know, your decision tree. Decision tree, guys, it follows sum of product. Sum of product. This sum of product is also called as your SOP. What is this? Famously, this is called as your disjunctive normal form. Decision tree follows your sum of the product, which is your disjunctive normal form. For a class, what happens that for a class, every branch from the root of tree to a leaf node having the same class is called as your conjunction or product. Conjunction of values. Put me in this way. Let me rephrase it. Conjunction of values. Different branches ending in that class is called as what? Disjunction. Disjunction or sum. Now, the primary challenge over here is, or in the decision tree, I would rather say, is to identify, which attribute do we need to consider as the root node at each level. This is the main challenge in the decision tree implementation. That is to identify which root node we are going to, consider as the, which attribute we are going to consider as the root node on each level. Handling this is to know as the attribute selection. When we handle this situation, this is called as the attribute selection. We have different attributes, right? We have different attributes. So we are also having different attribute selection measures to identify your attribute, which can be considered as your root node at each level. This is how you counter this issue, which is the biggest challenge when we talk about decision tree method. Again, I would like to throw some light again on your decision tree working. We have discussed, but I would like to exaggerate a bit on working of decision tree. The decision of making strategic split heavily affects a tree's accuracy. All right. Now, the decision criteria are different for your classification and regression tree. Both are having, different criteria for this. Decision tree uses multiple algorithms, guys, to decide to split a node into two or more subnodes. Now, when it is splitted into two or more subnodes, the creation of these subnodes, increases the homogeneity of resultant subnodes. In other words, if I were to say, then we can say that the purity of the node increases with the respect, or you can say with respect to your what target variable. The decision tree splits the nodes on all available values, and then after splitting, it selects the split which results in most homogeneous subnode. The algorithm selection again is based on the type of the target variable, and it can be many things. It can be one is your ID3. One is C4.5, one is CAR, that is of classification and regression tree. We have something called a CHAD. CHAD is nothing but your, cheese for automatic interaction detection, performing, various multi-level splits. All these are the things on which your algorithm selection can be made. Now, talking about your use of data, use of cybersecurity, decision tree in cybersecurity. When we talk about cybersecurity experts are trying to find solutions to prevent cyber attacks. And one of the main solutions is to improve cyber situational awareness, which leads to an extensive overview of your current situation in cyberspace and gives prediction ability to the managers to prevent future cyber threats. As in, if I were to give you an example of a credit card, a person who made a credit card transaction, every bank is having its own, risk assessment officer. Or if not risk assessment officer, then they will be having your risk assessment team. Whenever a transaction is made using a credit card, all the information regarding that credit card transaction is being displayed on a dashboard. And these risk assessment officer and team, they keep an eye on this dashboard. Sorry, this is not a dashboard. Yeah, this is a dashboard. And it tells whether it is fraudulent or not fraudulent. These are the cases of cyber fraud, right? When we talk about your intrusion detection, in this case, we can use our decision tree more efficiently, right? If we have, some malicious kind of mail, online transaction, or online fraud, all these are the cases where we can use our decision tree to take the informed decision. Then we have something called as your attribute selection measure. Attribute selection method. Or rather, it will be attribute selection measure. Now, suppose if a data set consists of n number of attributes. Again, suppose our data set is related to, say, your intrusion detection. It is having n number of attributes. Then, deciding upon which attribute to place at the root or at different levels of a tree is or as your internal node. Now that is a complicated. By just randomly selecting any node to be the root, that is not going to solve our issue. Now, what will happen that if we follow, say, a random approach, it is going to give us bad results with low accuracy, and we do not want that. So, for solving this attribution selection problem, some solutions were devised, and there should be some criteria. There should be some criteria, or some people who analyze the situation, they suggested some criteria. One is your entropy. Another one is your information variance. We have something called as a gene index, right? We have gain ratio. We have reduction in variance. If there's a lot of variance, we do reduction in variance as well. And then we have chi-square. Now, what will happen is that these criteria, they will calculate values for each attribute. Those values are sorted, and attributes are placed in a tree by following the order. What order? the attribute with high value. In case of information gain, I'm saying the attribute which is having the highest value is placed at the root while using your information gain as a criteria, information gain. We assume the attributes are categorical, and for the Gini index, attributes are assumed to be continuous. Same way, means every, these suggestions are having their own strength. This is how you are going to counter the issue of attribute selection. This is how you are going to counter. Okay. Now, all these things are fine. But again, the question arises, how to avoid overfitting in decision tree? This is also a big question in front of us. How to avoid overfitting in decision tree? The common problem with decision tree, especially, it is having a table full of columns. That when you have a table full of columns, they fit a lot. Sometimes it looks like, if I were to say, it looks like a tree that, memorize the training data set. Now, if there is no limit set on the decision tree, what will happen? It is going to give you 100% accuracy on the training data set. Because in the worst case scenario, it will end up making one leap for each observation. One leap for each observation. Right. Thus, what will happen? This affects the accuracy when predicting samples that are not the part of your training data set. Getting the point? So, how to remove the overfitting? First process is your pruning decision tree. And second one is your random. Through these two techniques, we can counter this issue of overfitting. What happens over here in pruning decision tree? The splitting process results in fully grown trees until stopping the criteria is reached upon. But the fully grown tree is likely to overfit data, leading to poor accuracy on the unseen data. So when you are using the pruning, you trim the branches, as in you remove the decision nodes starting from the leaf node, such that the overall accuracy is not disturbed. Now, this is done by segregating your actual training set into two sets, that is your training data set and validation data, so on and so forth. When we talk about random forest, now this is an example of what, guys? This is an example of ensemble learning, in which we combine multiple machine learning algorithms to obtain what? To obtain better predictive performance. Getting the point? This is how we are dealing with it. Again, there's a question which arises, okay, this is fine, but which model is much better, your linear based model or your tree based model? This is the question. Well, what happens is it depends upon the kind of problem you are solving. If the relationship between the dependent and the independent variables is well approximated by a linear model, linear regression will outperform your tree-based model. But if there is, to say, a high non-linearity and complex relationship between the dependent and the independent variables, your tree model will going to be outperform your regression model. Okay. This is all what I wanted to discuss about the decision tree. Okay. So here, guys, I have done something for you. That is a network intrusion. I have, tried to find out the network intrusion detection. And here I have used various models. I've used a naive-based model also, a logistic regression model also, KNN model also. All these things I have done. Let me quickly show what actually happened. I have first of all imported all the relevant modules. I've imported your matplotlib. I've imported your, matplotlib .pyplot over here, and pandas, numpy, cmon, epsilon, imdlearn, all these things I've imported. I have imported your warnings as well. And from the warnings, I've imported something called as your ignore. Why? Because, if someone is making an intrusion in the network, we need the warning that is going to tell us, or you're going to warn us, or, ignore or take the informed decision. All these things are done. Then I have, done all these settings, that is pd.set underscore option, display.max columns dot none. All these things I have done. I have initialized the parameters over here, axis, x-axis, what will be there, y-axis, what it is going to be there. And then I have used the data set. Now, the data set which I use, I splitted that data set into two parts. One was your training data and one was your testing data. Here, if you see, I have imported the data set into two parts. One is your train data and one is your testing data. When I say train.head4, it is going to give me your top 4 values over here in the pandas. In this I have done is spider. If you see over here, I have loaded the data set. I have loaded all the required information which was there. Everything I have done. And if I was saying head, it was giving me top 4 values. If I were, finding out all the insights from this, I have taken out. Then here I'm saying that print data has this many rows and columns. By what? Formatting the shape of your trained data. Starting from 0 and for training dot shape is starting from column number 1. This is what I have done. Then again I have said test that just dot head 4 means again it is going to give me your 4 columns. All these things I have done. Now when I said train dot describe, it has given me all this information. What is my, we know when we say, data set dot describe, it is going us to give your mean value. It is going to give us your standard deviation. It is going to give us minima, maxima, 25th percentile, 25th percentile. All these things I have found out over here. And the same thing I have done in my Jupyter notebook as well. I prefer Jupyter notebook more because, as a data scientist, Spider is good for learning. But in the real world scenario, what happens is that you need to work on your Jupyter notebook only. Or most of the organizations, they ask you to work on the Jupyter. Then I have loaded the data, all these things. I have done my EDA over here. I have done my exploratory data analysis over. I have found out your, total counts of the values. Over here, I have found out for the training data and the testing data. Then what happened was I was removing your redundant column from this particular column called as num underscore outbound underscore CMD. I have removed this from what? From your training data as well and from your testing data as well. Then when we want to find out whether there is an attack or not, I am using the attack class distribution over here. Train class dot value underscore transfer. Then I perform, I did my scaling using your numerical attributes. I did the scaling from epsilon. I imported a standard scalar over here. Then I said that I have created a variable called as a scalar, which is containing your standard scalar. And here what I did was I have extracted your numerical attribute and I have scaled it from 0 mean and your unit variance. How? I have initialized these parameters. Columns is equal to train dot select underscore data, include your float as well as your integers dot column. On my train data, I have done the same. On my testing data, I have done. Again, here I have used transformation, hit underscore transform. This is what I have done. Now what happens is when I say all these things are done, I'm turning back the results into what? Into a data frame. So here, this is what I am doing. PD.data frame, it means whatever results I got, I am turning back into a data frame over here. Okay, moving on. Now I have done encoding over here, and for encoding, I have used label encoder from your sklearn.preprocessing. After importing that, I have extracted your categorical attributes from what? From your training as well as your testing data, both over here in these lines. And then I have attributed, once I have extracted those, categorical attributes, then I have done the encoding on them. See here, this is your training category, this is your testing category, encoder.fit underscore transform. Stat train.apply, this is going to apply my encoding on my training data category and on the testing data category. And I have created a separate column for my encoded data, that is stat underscore by tree. This is what I have done. Then here I have, again initialized the parameters and I have done the concatenation over here of what my trained data and as well as my encoded, whatever the data, values I have done the encoding upon. I stored it into a new variable called as ENC train. I am concatenating that and I am concatenating the data frame called as st underscore train dn. Again, all these things I have done and then I have tried to find out the shape of these things. Now I'm doing the feature selection and for that I have used something called as a random forest classifier. Here what I'm doing, I am fitting your random forest classifier on my training data set. I am saying rfp.fit train underscore x and train underscore y. And after applying this random forest, I'm trying to extract the important features over here. This is how I am trying to extract the important features. I am, plotting the importance also. I have plotted a figure over here, bar plot over here. Then I'm importing RFE over here and I'm importing ITER2. RFE is your random forest classifier. Now here, what is happening? I'm creating my random forest model and I'm selecting 10 attributes. And then I am summarizing your selection of these attributes over here. And then when I say selected underscore features, it is going to give me all the features which I have just selected. Data set preparation over here I am doing by what? Training, testing, and splitting. This is what I am doing from sklearn.models. Again, here I have classified your, initialized your parameters. Fitting model. Now, what happens is I have used various models. If you look closely over here, all the values which I got, I am using various models over here. I am using KNN. I'm using your logistic regression. I'm using your knife base. I'm using your decision tree model. Based on these models, whatever accuracy I was getting, decision tree was giving me the best answer. Hence, I went ahead by using the decision tree model. For training, for your implementing of KNN, what I did was KNN underscore classifier k neighbors classifier n underscore jobs is equal to minus. All these are the parameters which I have given. Logistic regression is what I have used. Night days I have used already. And after doing all these things, I did my model evaluation, in which I got that my a decision tree is giving me the best accuracy, and hence I went forward and used my decision tree for my analysis. This is how I have performed my network intrusion detection using the decision tree as well as the various other. It is not like you can use only one model. You can use various models. The one which is giving you the best accuracy is the one which you should go forward. Okay. So guys, this was all about our decision tree and using it as a use case of network intrusion detection. I hope you guys liked this session. We will be meeting again tomorrow, and tomorrow we will be discussing about linear regression. Again, see here, I have used, no, here I have used a logistic regression. Okay, I will be using the linear regression also, and I will be coming up with another very good example to discuss with you guys. So thank you so much guys for joining. This is where we are going to stop the session for today. Have a wonderful evening, guys, and yeah, happy learning. Keep on revising the thing. All the best, guys. Thank you.
Sir, please share this code, sir.
Yeah, people on the last day, I will be sharing. I have the all the email IDs you people have shared on the last day of this domain analytics. That is your day after tomorrow. I will be sending you the email which will be having all the codes and the data set which I have used during these 8 days of training. Whatever use cases I have seen, I have showed you guys what was the data set I used, what was the codes I have used. I'll be sharing this. Now this can be either in your IPYNB format or IPY format. You know how to work upon this, so you can easily make it up. So I'll be sharing all these things on the last day, guys. Don't worry. Okay, buddy.
Okay, sir. Thank you.
Yeah. Okay, guys. Bye bye, guys. Thank you so much for joining. Have a wonderful evening. Bye, guys. Bye. Thank you.